Hi there, here we are in a simulation program, FET, and we have here a very simple electromagnet, the simplest you can imagine. It consists of a battery where I can change the voltage of the battery and just a single coil. Notice that this electromagnet does not have a core in it, no ferromagnetic material, what you would see in most electromagnets, but this is just a simple coil and a battery. And we're going to do some measurements with this. So you've been asked to predict what the effect is of the electromagnetic strength based on the number of coils, and that's what we're going to find out here. So I have some things that I can change here on the right. So first of all, I can say show electrons. That's always fun. I guess they're represented by these little blue things here. Now, they're not moving because there's no connection. There is no battery. You could almost say this is disconnected. The battery is not turned on. Okay. I know you can't really say it turn on a battery, but it's just assume it's at 0 voltage, so no battery power. What I'm going to do is I'm going to change this to 2 volts. All right. Oh, actually, first I'm going to put in the field meter. All right. So the field meter is the magnetic flux meter. All right. And this device here, you can move it around. Now, right now, it's 0 everywhere because the electromagnet is turned off. And the magnetic field is measured in a unit here, which is called Gauss. It's not too important what that is, but it measures the magnetic flux. So it's actually not directly the magnetic force, but it is absolutely directly related to the magnetic force. So we can use that. It's a little bit more complicated, as you saw in the video a couple of lessons ago. But so Gauss is the unit for magnetic flux, which is a measurement of the total magnetic field which passes through a given area. So this little area measures how much magnetic field lines pass through this, if you will. Okay, right now 0. So let's make this a little bit more interesting. Let's turn this on, and I'm going to go to 2 volt, right away. And now you see I have some measurement here. There's an X and a Y component based on the angle that we have actually. I'm not going to focus on that too much, but what I will show you, if I move this around, if I go further away, we see that, the numbers really change, right? So we can go everywhere. When we're in here, it's really high. When we move away from it, it goes lower. So I'm going to find a point here, and I want to be a certain distance from it. I'm going to find this point here. And I really want to get the angle to get 0. I think I need to go a little bit down for that. Oh. Well, close enough, I would say. Actually, let me put it down a little bit more. Okay, so I try to put it directly on one of those arrows, and that'll become clear later why I did that. Okay, so what do we see here? Well, with a single coil, 2 volts, the magnetic field flux strength is 5.6. So at this point, you can pause the video and write down 5.6 in your data table. I'm now going to change the number of loops to 2 loops. And what do you see? The number changes. How does it change? I'm going to let you think about that. All right. But the next number for 2 coils, you can write down 11.2. All right. Give you a moment to pause. 11.2. And then we're going to go to 3 loops. Oops. 16.8. So you can write down that number, 16.8 for 3 loops. And finally, 4 loops, 22.39. Okay, so you've written down all those numbers, and take a moment, write those in your data table.